All right, so we're going to talk about the conditions for parallelograms. So essentially what we're doing is your learning target is I can prove that a given quadrilateral is a parallelogram. So we're going to do a couple of theorems here that make up quadrilaterals, that make quadrilaterals parallelograms. And essentially what we're doing is a lot of the same thing as yesterday, except now we're saying that if this is a quadrilateral that has these things, then you're going to be a parallelogram, okay? So to get this started, though, I want to go back to kind of some of this. You may have heard of those jokes by Jeff Foxworthy, you might be a redneck. One of them, you might be a redneck if you ever cut your grass and found a car, right? Or you might be a redneck if you burn your yard rather than mow it, or things like that. So we're going to do the same thing here, except we're going to be talking about parallelograms. Okay, so you might be a parallelogram if one pair of opposite sides of a quadrilateral are parallel and congruent. Okay, so what that means is that we have parallel sides by this marking, and they're also congruent. That means that is going to be a parallelogram. Okay, you might be a parallelogram if both sides, or if both pairs of opposite sides are congruent. Okay, so if both opposite sides are congruent, it might be a parallelogram. Okay, don't laugh too much here. This one's a good one. You might be a parallelogram if both pairs of opposite angles are congruent. Okay, so if both of these angles opposite each other are congruent, then it might be a parallelogram. Okay, you might be a parallelogram if an angle is supplementary to both of its consecutive angles. So if you have this angle right here and both consecutive angles are supplementary, meaning they add up to be 180 degrees, then it's going to be a parallelogram. Okay, and then this last final joke here is you might be a parallelogram if the diagonals of a quadrilateral bisect each other, meaning that these two, the sides opposite, or those sides AZ and CZ are congruent, and BZ and DZ are congruent. They bisect each other, they cut them in half. So essentially, just to kind of reiterate this, the key concept here is in order to show a quadrilateral is a parallelogram, we can prove that the quadrilateral has one of the following conditions. Okay, if it has one of these conditions here, then that means it's a parallelogram. Okay, and these are essentially the same thing that we had above, just a few more, or one more here. It says both pairs of opposite sides are parallel. One pair of opposite sides are parallel and congruent. Both pairs of opposite sides are congruent. Both pairs of opposite angles are congruent. One angle is supplementary to both its consecutive angles, or the diagonals bisect each other. If any of these are true in a shape that you're looking at, in the quadrilateral that you're looking at, then it's going to be a parallelogram. If one of any of those is true, then it's going to be a parallelogram. All right, example 1 says that we need to show that JKLM is a parallelogram for A is equal to 3 and B is equal to 9. Okay, so the very first thing we need to do is we need to kind of take a look at what could we prove. These are our 6 different options to make this quadrilateral a parallelogram. Do we know any of the sides are parallel? And we can see by the markings, there's no way that we can really prove that because we don't know any of the angles or anything like that. One pair of opposite sides are parallel and congruent. Again, we don't know anything about the parallel. Both pairs of opposite sides are congruent. And we see that on this shape, we could prove possibly that both sides are congruent if we were to know what A is and what B is. And in this given problem, it tells us exactly what A and B are. Okay, so we can show that this parallelogram, or this quadrilateral, is a parallelogram by kind of solving for these things. Okay, so these two need to be congruent and these two need to be congruent. So let's start with A here. We've got 15A minus 11 needs to be equal to 10A plus 4. And it gives us that A is already equal to 3. So let's go ahead and plug in A, or 3 for A. So 15 times 3 minus 11, that needs to be equal to 10 times 3 plus 4. And 15 times 3 is 45, minus 11 is equal to 30 plus 4. 45 minus 11 is 34, and 30 plus 4 is also 34. So that side checks out. These A's are congruent. Now we need to check to see if these are congruent. And if those are congruent, then we can prove that this is a parallelogram. Okay, so we should have 5b plus 6. That needs to be equal to 8b minus 21. Again, we're going to plug in 9 now for b. So we have 5 times 9 plus 6 needs to be equal to 8 times 9 minus 21. 5 times 9 is 45 plus 6 is equal to 8 times 9 is 72 minus 21. 45 plus 6 is 51. 72 minus 21 is also 51, and so that checks out. That is true, and because both of those are true, we can know that this shape is going to be a parallelogram. Example 2 wants us to determine if the quadrilateral is a parallelogram and then justify our answer. Okay, so let's go ahead and do that. We've got, if we bring our key concept back out here, if one of these is true, then we could tell that the quadrilateral is a parallelogram. Okay, do we know that both pairs of opposite sides are parallel? Well, no, we don't know anything about if they're parallel or not. Do we know one pair of opposite sides are parallel and congruent? No, we don't know that. Do we know both pairs of opposite sides are congruent? No, both pairs of opposite angles are congruent. We see that one of these angles are congruent, but we don't necessarily know that about this other angle here. So we don't know that. And do we know one angle is supplementary to both its consecutive angles? And right there we see that we could possibly prove that these angles are supplementary. Okay, so if this is our angle right here, 73 plus 107 is 180. So the consecutive angles from here to here and from here to here are equal to 180. They are supplementary, which means that these two, or this shape is a parallelogram, or this quadrilateral is a parallelogram. So we can say yes, because one angle is supplementary to both its consecutive angles. And that's how we know the quadrilateral is a parallelogram.